terminology we're going to be used throughout the session. From there, we're going to go into some how-tos, all the way from how do we do an Azure migration from some of our servers and VMs over into more of a kind of a cloud optimized approach, and then finally into that app modernization side that we've talked about. And then finally, we'll talk about just some best practices and kind of wrap up with things that you should know and things that you look out for. So in terms of why modernizing, really the world is moving very fast and user demands are increasing across the board. Everyone's looking for new features and convenient solutions to really solve their problems. Most companies, either whether they're finance companies or retail companies, are finding themselves having to really run like a software company where they're having to maintain their own kind of portfolio of applications. And within those portfolio of applications, they're having to make sure they're deployed, optimized, and be able to make changes on them quickly. And that oftentimes requires software development teams within companies that is not their primary focus. In addition, really people are using integration struggles as a kind of an opportunity to modernize. When we start building up all these different applications, we end up with these application silos, and within each of those silos, they ultimately struggle to kind of connect with other applications as maybe an acquisition happens and we bring on new pieces of software, or we're integrating with some sort of a SaaS offering. Being able to integrate those with other systems can be tricky, and the cloud offers a nice way to make sure that those connections are easy to be made and they're in a common place and all consolidated. The last one is around data intelligence, and we work a lot with Microsoft. This last fiscal year for them was kind of the year of data, and we're seeing a lot of application silos where data was kind of a byproduct of those applications, where now data is really becoming part of the forefront. And once everything's kind of starting to be consolidated, we can start looking at combining those data sources together and really getting some advanced data. But even moving beyond some of the historical look at data and start looking at some advanced analytics around predictive data, machine learning, and artificial intelligence really unlocks that ability to do a lot more with the data that you have. I know there's a lot of government folks on the call today, so I did just want to kind of throw out this quote from FedTech magazine. I think we see a lot of the main driver for modernization of applications is around the total cost of ownership for running software. Having to maintain data centers and having to maintain all the servers within the data centers is often quite costly, and there's a number of optimizations that you can make when you move them to the cloud. But the other big, driving force for this is allowing agencies to kind of clear out some of the dead wood in some of their application portfolio. So Microsoft has done a great job with some of their tools to help with the migration, but there is still a big lift within companies to make sure that they can get a hold of what their portfolio looks like, what type of applications are out there, make sure they all have proper ownership and governance, and then get those applications migrated over. There's a ton of benefit just really kind of in clearing out some of that information that I think is that companies are finding a lot of benefit from as well. In terms of some of those migration triggers, if we really start at the bottom, the data center contract expiration and software end of support, these are often kind of ticking time bombs for companies where they have a set date in the future and they know they have to get off of a data center, or they know they have to migrate some software, and forces companies to move up to the cloud based on a certain timeline. It could be often accelerated because of that. But that's still a very big driver for people to move to the cloud as an opportunity to, before they renew a contract, do that migration and get that cost savings as part of that. Moving up from that, we have really the ability to kind of quickly integrate some acquisitions. If companies acquire another company, you need to kind of migrate them in together rather than trying to kind of combine two data centers together. Migrating them up to the cloud becomes a kind of a central place to get those pieces of software integrated properly. And then also being able to innovate on new features as business units come out with new ideas, new technologies. They start opening up pieces of software that have been used for a little while. That becomes an opportunity to move it up to the cloud because there's a new deployment that's going to be coming up based on some new features that they're releasing. Moving up to the top left, urgent scale and COVID response. Those really kind of were tied together for us as part of COVID-19. We work a lot with some government legislatures. We worked on a remote voting application. So as you can imagine, with a House legislature, they're essentially doing voting whenever the house is in session. So it's not a full-time sort of server need. It only needs to be run at a certain period of time. But when it does need to be run, we need to scale it up really quickly and allow people to vote in a very rapid fashion and poll and get everybody up to date at the same time. Over on the right-hand side, if you're finding that your company is really bogged down with kind of security threats and dealing with security issues and also software and hardware refreshes, a lot of that is really out of the question and not necessarily anymore as you start getting into the cloud environments. So companies will often look at migrating into a cloud provider so that they can eliminate some of the overhead that comes from having to manage some of the software and hardware refreshes. And then in terms of the security threats, I often like to think of I like to tell people that Microsoft has thousands of security experts that are online monitoring your servers and all of the cloud and on a real-time basis, and they're spending way more on some security monitoring and analysis than your individual company would be able to do. So I just have faith that they're doing a lot in terms of monitoring the security, and the cloud is very secure. For many applications, and there's proof to that in some of the applications that you'll see out there. So wanted to go just a little bit to some of the basics. When we're talking about an overview of what PaaS is, we're talking about the idea of a platform as a service. So if we start over on the left-hand side, we have kind of information or infrastructure as a service. And if you're in a situation where you have your own data center, infrastructure in a service can be very nice because you don't have to worry about the physical data center electricity or any of the building space and retail and real estate rather. From a networking perspective, you don't have to worry about switches or firewalls, and also you don't have to worry about actually managing the physical servers and the storage that's needed to run those servers. Moving up, kind of the nice place where the cloud has a ton of benefits is in this platform as a service. And the idea here is that the platform actually manages everything, including in this IaaS offering, but it also manages your operating systems, software versioning patches, upgrades to security software and the operating system software, but also some of the development tools that you need for monitoring and analytics to make sure your servers are running at the right capacity and they're optimized to make sure that you're not overspending on capacity for some of those servers. The last one, and we are seeing a lot of this as well, is just more SaaS offerings, and that's software as a service platforms. When we're talking about build or buy solutions, if your company has an option to buy something off the shelf, SaaS can typically be a good option where you don't even have to manage the application and the code, so everything is managed for you. Email is a good option, is a good kind of example of that nowadays. Many companies are using Microsoft 365 to manage some of their email services, so they don't actually have any data center that's running email. They sign up for Microsoft 365, and as part of the Exchange package, they get the SaaS offerings. So we talk about the benefits of the platform as a service. This is a very similar side to the past one, but I really just want to kind of get home the point that on the left-hand side, if you're running things on premises, you're managing everything by yourself. So you're managing everything all the way down from the networking, storage, and servers all the way up to the application. The infrastructure relieves a lot of that pain by having that vendor like Microsoft Azure or AWS in order to manage the networking, the storage, and the servers. Even the virtualization of the virtual machines that you're going to be using will all be managed by the provider, and all you have to worry about then is the stuff on top of that. You do still have to manage the operating system and the middleware in those scenarios, and that's where the platform as a service becomes that sweet spot, because at that point you have your cloud vendor is managing everything all the way up the stack from the networking all the way up to the runtime, and all you have to worry about is your application and your code. And it gives you a very nice option to focus on what's important to your business. This next slide is the cloud maturity model. It's taken directly from the Microsoft kind of cloud application framework. This is a very well, the cloud application framework, which I'll just kind of quickly show, is an excellent resource for you as you are going through a migration. It is available under a URL aka.ms/CAF for a cloud adoption framework. This really kind of sets the framework for a path in which companies are going to have success migrating over to the cloud, starting with kind of a strategy and a plan, and then getting into kind of becoming ready to start migrating, actually performing the migration and innovation, and finally governing and managing to make sure it's all running as expected. So so in terms of the maturity, oh, sorry about that. So in terms of the maturity, the very kind of the first two are lower code, easy options to kind of get you migrated over to the cloud. The first one is really just a lift and shift, where we're talking about taking VMs that you might have running in a local data center and moving those VMs up into a cloud provider. It's a very there's no code changes at that point. You're really just taking the kind of the operating system and the deployed code that's out there and then moving those up into the cloud. The next one over is cloud optimized, which is actually the big part that I want to demystify as part of this webinar today, because there's still not a lot of code needed to migrate over to a cloud optimized approach. So a lot of companies will look at this lift and shift, and they'll really just jump to that as kind of an easy win to get over into the cloud. But it's not too much of a lift to get into the cloud optimized approach, where you're running native cloud services and you get yourself set up to start doing some of the innovation and the modernization. And then the last part is really App Modernized, and that's where your application is starting to take advantage of some of the features within the cloud that are a little bit more advanced and might require some additional code changes or architecture to really start taking advantage of some of the cost benefits to using the scaling out features. But also, being able to kind of spin down servers and kind of set up redundancy within some of your services. This is not a linear path, so there's a number of different ways in which you can go about this. It's actually, something where if you jump directly from an on-prem to a lift and shift, you can kind of get stuck there. So if an application needs to be modernized, it's not a bad option to just go ahead and just plan to get an application from an on-prem all the way over to not modernized. But overall, I'm going to be using this slide to kind of go through some of the discussion for today. So in terms of the how-tos, I really want to talk about the first path first. So when we're taking an existing application that's on-prem and we're doing a lift and shift, Microsoft has a number of tools in order to get you over, to get your VMs migrated over. If you want to go about doing this, the Azure Migrate service is going to be your friend. So I will jump over to the Azure Migrate service so you guys can see that. So this is available through the portal under Azure Migrate. If you search for Azure Migrate, it'll pop up. From here, you have an overview. The left-hand side, where we're talking about actual Windows, Linux, and SQL servers, this is where you're going to go for doing your lift and shift and modernizing your application, moving your VMs up into the cloud. So if you click on here, you will see everything in the Azure Migrate platform is broken up into two phases. The first one is the assessment, and the second one is the migration. So under the assessment, there's a number of different tools that are available. If you look down here under more tools, you'll see there's tools like MoveAir and the Unified Cloud, which are two ones that we use for our clients quite a bit. For this example, I'll just kind of show the Azure Migrate. Within the Azure Migrate, what you can do is you have two options. The first one here is discover using an appliance. What this will do is that you'll download this appliance and you'll hook it onto your VM host. It'll scan the network, scan for what VMs are out there within your on your server, and it will provide you with a list of what the performance is, what the usage is of all those different servers, and give you not only kind of a count of the number of servers that you need to migrate over to, but also give you some recommendations on how to size those servers appropriately so that they give you the best cost benefit. If you don't want to install something locally on your network and you want to you already have the information provided, there is an approach to use a CSV here. So I've downloaded this CSV. I can show it over here. Essentially, what we have with this is a number of different, just basically details about the servers that you're going to be bringing over. And as you see over here, you also have some information about the utilization. So not only do we know the size of the VMs, but you would, and the operating system, but you'll know how well they're utilized. So if we need to scale them back, you'll have that data available as part of your migration. All right. Jumping back over the slides. I hit the wrong button again. Okay. So after the Azure migration, sorry, this slide itself is not so much about the lift and shift migrations of the VMs. Microsoft and its partners such as Tallan do help customers, with a Microsoft Azure migration program, which is called their AMP program. It works with customers to actually get those VMs shifted up there. If you're interested in that, we can provide more information. There's also more information here at the azure.com/AMP URL if you're interested in that. So the next one I wanted to talk about is the idea of cloud optimized. And again, I mentioned there's very minimal code changes to this. And the principle behind it is really saying, instead of taking the full VMs over, we really just want to, separate out the application into two parts, both the data and the code side. And then from there, we're able to take those pieces and we're going to deploy them to the managed platform as a service counterparts for those two different pieces. And in this case, if we're looking at a .NET application, we're moving our data from a SQL Server VM that might be on premises into either an Azure SQL managed instance or an Azure SQL database. And on the code side, we're moving that over from an IIS on a Windows machine over into an Azure App Service, which is a dedicated app service plan for hosting web applications. In terms of app services, there's a number of different options to kind of host app services or applications in general. If you're doing something like a batch job, there's a lot more options. You can use Azure Functions and do some serverless code within an Azure function. There's also Azure Batch, which is a good recommendation for something like that. We're talking about microservices, then you can start talking about containerization, possibly using something like Azure Kubernetes services or Docker. And then when we're talking about web applications and end-tier applications, that's going to be the focus of some of our talk today. Where we're looking at existing .NET applications and how would we migrate those over into an Azure App Service within for .NET within Windows. All right. So there are two tools there. We saw them a little bit on the Azure Migrate page. There is the SQL database migration assistant and a web application, which is the App Service Migration Assistant. So from a database modernization perspective, we mentioned moving the VM. So the very simple approach was the lift and shift. You're going to take a SQL server and move it up into an Azure VM. That's going to be kind of minimal impact, but really not doing much except moving a VM over into a different location. The other area, the platform as a side, which is the sweeter spot, is to look at either an Azure SQL managed instance, which gives you the full functionality of the SQL server that you get on a virtual machine, and any instance level functionality would be a part of that. And then the other option, which is a little more powerful and offers more scalability, would be an Azure SQL database. The downfall of that is that you lose some of the instance level functionality, and I'll talk about that on some of the next slides. So in terms of the platform as a service offering, these are your two kind of database approaches to move your SQL Server database over into Azure. If you do have other databases, Azure does have counterparts on the platform as a service side as well for both MySQL, Postgres, and another number of other database providers, if that's what you're using. So this slide kind of shows a little bit of a comparison of the different services. So within Azure, with your SQL Server on an Azure VM, it's the same deal with IaaS, where you're still managing the operating system, you're still managing all the database and updates and the backups and recovery. If you move over to an Azure SQL managed instance, you still maintain some of the SQL instance level functionality that you might need, whether that's the .NET Core CLR or any of the other instance level features. But you also have the backup and recovery operating system is all managed by Microsoft. The last one over here is using the Azure SQL database. You lose the instant SQL level features, but you get some cost improvements as well as some scaling improvements as you decide to scale that out. And you still maintain all the platform as a service benefits that you would have from the Azure SQL managed instance. So this here is a screenshot of the Azure Data Migration Assistant. As you can see, what it does is you attach it to an existing connection string for your machine. You'd run the migration the assessment. After the end of the assessment, it'll show you what sort of features you may have on there that are unsupported. In this case, it's using Windows authentication and it's telling you that that's not supported. And in this case, for most applications, you could switch that over to a different type of SQL authentication, and then your application would run as expected, and you'd be able to migrate this over. All right. On the application side, as we mentioned, IIS on the virtual machine. If you did that lift and shift approach, that's probably the what you'd have running. So you're going to have local IIS on that virtual machine. On the platform as a service side, you have an Azure App Service. That's going to be your main location to deploy all your web properties within Azure. And from a base level perspective, we can create an app service. You can use Visual Studio to publish your application. You can even publish deployed source code if you have it, which I'll show as part of this migration assistant. But the other alternative, which is a little kind of more maintainable in the long run and a little better for operations, is to use something like app service deployment through Azure DevOps or GitHub Actions. Both of these could be set up as part of a CI/CD pipeline, so that as changes are made from the development team, we can make sure that those get deployed up into different app services. You can manage different deployment slots as part of that, so that you can have both production and dev environments that are all managed through that deployment pipeline. So what type of .NET apps are ideal for app services? Really any sort of ASP.NET applications, whether that's web form, MVC, or even a web API. WCF services are also available. So if you have older applications that are using WCF services, really any .NET application is going to work just fine. And really any sort of self-containing web application that has services talking to a database are going to be ideal for an app service. There used to be cloud services and web apps, and now in Azure it's all been combined under just an app service. So it's really more the generic term for any sort of app service and web service that you'd want to be deploying within Azure. So in terms of just some of the benefits of Azure App Services, a lot of these come down to some of the benefits of the cloud. You have, a lot of high productivity in terms of some of the telemetry and the analytics that you're able to get connected into Visual Studio, so you can monitor your application, make sure it's running right, also do the debugging that you need to do. It's fully managed, so all those platform as a service benefits of having the operating systems be managed and be updated and be patched, be protected from a security perspective are all going to be included in there. The auto scale functionality. So, if you're running your web service or your web application in a local data center right now, you're going to have some sort of a load balancer and then run multiple different backend web servers to feed that load balancer, and you may be manually spinning those up and configuring those in your load balancer as scale needs change. In this case, with Azure App Services, you have some auto scale functionality, which can automatically listen to the performance of your application and will automatically scale your application up and down based on the load that you're currently seeing. There's a total built-in load balancer, dedicated IP, really everything you would need for a modern web application is going to be built in and be fully managed by Microsoft and by the Azure platform. And then finally, it's really enterprise grade. It's got, all the higher end features, the SSL, WebSockets, all the resiliency and high availability and data recovery that you would need and disaster recovery that you would need is all kind of something that Microsoft has experience. They've worked with large clients on, so they have experience, and the platform supports managing it in a number of different ways and being configurable for a number of different needs. So in terms of app service tiers, there's a number of different plans. They go all the way from just a simple free plan to kind of a penny and a half per hour for a shared environment, which is great for dev and test scenarios. Moving up from there, you kind of have all the way up from 7 cents all the way to 30 cents, depending on the size of the server you need. And you'll also notice that, as you in a typical data center, you may decide to scale up, where you're going to take your application and just throw it on a bigger server. A lot of the Azure app services are kind of designed in order to scale out as well, so that you not only are taking a single web server and maybe making it, just giving it more memory, but you're spinning up 2-3 servers within a smaller scale, and kind of reducing the cost by bringing the using many smaller servers than one big server. So in terms of just migrating a web app over to an Azure app service, there is the Azure app service migration tool. What this will do is it will either it'll take your application from an IIS server, or it'll actually take a URL that you can pass in, and it'll run an assessment on that. From there, it'll ultimately give you an option to migrate that app service. But what that's going to do is it's going to take your deployed code on your server and migrate that up into an app service. So you're really just taking deployed code and merging it up, so the DLLs are already compiled. A better approach would be to do more of an actual republishing of your application, which I think we're going to be showing later. So we'll hold off on that. But this tool is available for you if you have something where you want to move it over to the cloud, but access to the source code or access to a development team that manages it is kind of is going away. This gives you a nice option to still migrate your app and get it over to the cloud. In addition, and what the assessment actually checks is part of this compatibility checklist. So there's a couple things that they're looking out for. Most of these are things that you can get around. Port bindings might be an issue if you're running multiple web applications on a server. At that point, what you would do is deploy it out to multiple app services within Azure. The two big ones on here are something like no global assembly cache. If you're using some sort of an old DLL or something that's that had to be registered in the global assembly cache, and that framework is not supported any longer, that can be an issue moving over, and you would still have to require you to do more of an Azure VM, an Azure VM, or the no COM or COM plus components is one of the other big items. I'm going to mention it briefly, but Docker and Azure Kubernetes services and containerizing your application is another good approach to that. It's kind of sits right in between the lift and shift and some of this cloud optimized approach, but you can package up your applications a little differently within a Docker container, and then it would allow you to still use some items that are possibly more legacy components that wouldn't work in an app service. Talked about this a little bit with the Azure DevOps pipeline, but this is really the sweet spot, is if you're able to set up your application to be deployed and migrated through Azure DevOps. At this point, what you're going to do is, take your code, get it into a repo of some type out in Azure DevOps or GitHub, and then create your Azure pipelines or GitHub Actions, and use that to ultimately deploy your application over to a target environment, get it tested, and then deploying it over to production. But having that pipeline allows you to create a repeatable deployment process, so that deployment process happens in a very consistent way, and you can test it, make sure it's good before finally deploying it over to production. So talked a little bit about the Docker and the Kubernetes services. This one is, becoming very popular. Azure, Docker containers is a very popular way to kind of combine services that are needed for an application in a nice condensed package that can be used for both for development as well as kind of production cases. It offers great functionality in terms of scaling out, but it is still kind of not taking full advantage of some of the platform as a services functionality. It's a nice middle ground if you're if you want to go obviously beyond just deploying VMs to the cloud. But if you do want to take advantage of some of the platform as a services, the containerization is not necessarily going to give you everything that you'd want from the full platform as a services perspective, but can be a nice middle ground. So I did want to at least mention the idea of deploying to Azure Kubernetes services or using Docker containers as part of your deployment strategy, because I think it'll certainly fit depending on the type of application that you're running. It's also very good in Azure Kubernetes Services, specifically for some of the orchestration that would be needed if you wanted to have a lot of different instances of the services running in a configuration where you needed to have some sort of fault tolerance to spin up applications as upon failures or upon different needs for the application to scale by itself. Okay. So the last one I wanted to talk about was the App Modernize, right? So the first two is really, again, minimal code changes. We're really just looking at, explaining to people that, hey, a lift and shift is an option. We can get you to the cloud. That's not a problem. Been doing that for years. It's a nice, easy way to kind of offset those data center costs. But it's pretty easy to just go a little bit further and start using the cloud optimize and use those platform as a services. So, really understanding the difference in your strategy choices between the IaaS and the platform as a services, and understanding that you can achieve platform as a service functionality with the cloud optimize approach with still minimal code effort. The reason I push the cloud optimize approach and I like it a lot is because it allows customers to, again, get most of their portfolio up into the cloud and start dipping your toes into some app modernization functionality and some of the advanced tools that are available in the cloud to modernize your application. But they don't, you're not kind of locked in where you would be with the lift and shift approach and your abilities to start using some of those app modernization approaches. There's also a number of applications that, are just, they require enough changes that app modernization is, re-architecting the application and rewriting it is going to be a better approach, but that typically involves a bigger price tag. And so it requires a lot more kind of thought in your plan of migration for how to deal with that type of application. So when I talk about app modernization, just want to highlight the kind of .NET application architecture as a good source for information about some of the modernized web application techniques that are available. Microservices is a big one, and being able to kind of use serverless functions to manage kind of a collection of APIs and orchestrate them through a web API management tool that allows you to have lots of smaller pieces of code that are running out there in the cloud and connecting to each other without having to have a big monolithic application that requires very large deployment processes around, and getting features out takes longer because of that. So the .NET architecture website is a good tool for kind of exploring some of those additional modernization features that you might want to take advantage of. Another good tool is Microsoft Patterns and Practices. They have a GitHub page where they published a number of different reference architectures. One of them I'm going to show right now is around their scalable web application. And what we have here is a web application. Actually, let me just show the application first, and then we'll come back to this slide. So here we have an application called What's for Lunch. In here, I can just go ahead and type pizza. And then I can also type something like sushi, let's say. We also have as an option for lunch. And then we'll also say tacos. So as I'm clicking on these, it's going and adding it to an Azure SQL database. This Azure SQL database this web application also has a web API for some of the database calls. So when you add those, it's going to the web API in order to update the database. But when you're trying to determine what you want for lunch, after you've added all these different candidates, the team members that you might be in an office with, or we used to be in an office with, who would go on and vote, there may be lots of people voting at once. So what this application does is takes the data from when you click here, so when you actually provide the votes, and instead of using that web API to actually update the database, which could cause some possible race conditions, they're adding those to a queue, and then there's an Azure serverless function that picks up items from that queue and goes and processes them on a separate instance. So as you see now, if I'm clicking on these, the votes are increasing, but it's still maintaining responsiveness, even though the database isn't being updated right away. So jumping back a little bit to the architecture for this, as you can see here, we have our web app, which is our app service plan with the web app, and there's actually a web API in here for the database side. But we also have a queue with a serverless function in here. So whenever votes are accrued on the candidate for lunch, it will go ahead and use that serverless function to kick off an update to the database, and then the web application will pull the database for any additional content. Over here, you also see we have an Azure front door, and the Azure front door uses a, allows it to kind of switch between an active region and a standby region. This is a nice technique for some fault tolerance. So as you're scaling up your application, if something breaks or shuts down, it can easily fail over into a standby region. So I want to show a little bit of the code for this. So I mentioned the voting application here. So in this voting web application, we have this voting controller. And as you can see, when we add a candidate here, it's just going into our client, which is the web API client up here, this voting data project. And if we go into this one, you'll see that it's just using entity framework here with an entity framework data context to add an item with this for this candidate here. So it's going to add async for a candidate based on the information that was provided. Back on the web application, you'll see it's slightly different when you vote. So when you vote for a candidate, we're actually going to use a queue client instead, and we're going to send the vote async to that queue. And what that queue does is it just starts retrieving any information and hanging on to it for processing later. And the way that's being processed later is through that Azure serverless function. And Azure serverless functions, if you haven't looked at them, are very cool. They're very lightweight API functions that you can have. You can have HTTP triggers, which would be the API. In this case, we're using a service bus trigger, which is based on a queue. And whenever an item gets added to that queue, this serverless function will spin up, and it will start processing any messages that are in that queue. So in this case, it's just a single C# file. And whenever that's received, it updates the database based on the ID that was provided. So just to kind of show that example a little further, over here is the Azure portal, and we have a resource group that's set up for this application. Inside of here, we have a number of different services that are provided as part of this sample. But we see here this service bus, which is where our queue lives. And then we can go into our entities, which is our queues, and you'll see we have a voting queue here. So you'll see history of votes that have happened over time as I was testing some of the stuff out. But what I'm going to do here is change the status of this queue to be receive disabled, which means our web application can send information to this queue, but our serverless function is not going to be able to receive them. It's going to be disabled from receiving anything. So now if we go back to our application, I can start voting for tacos, and you'll see it doesn't update right away. But the application's still responsive. Nothing's happening to the application. I could still add, more items here if I want, and the application still maintains responsiveness. If I come back to the Azure portal and refresh this, you will see that there's kind of 15 messages that are sitting out here in the queue. You can click into these and start exploring what those items are. But what I'm going to do is I'll just go ahead and turn this back on to active. And you'll see here that those messages are already picked up, and then this should pull an update to 22 based on those messages being picked up. So this is a small example, but it does show how adding new architecture to your application, specifically in this area where we know people are going to be having they'll be stepping on each other's toes, and people can be clicking in different places at the same exact time. Allows you to kind of make your application more fault tolerant and allow it to not be as kind of not break when things happen. And so in this case, introducing a queue functionality for something that's maybe long running or something that there's some high demand on allows your application to respond a lot better. So that's kind of the sweet spot that I really wanted to drive home around. Cloud optimize is fine. There's no code changes. You're really just taking your application and moving it to its proper platform as a service counterparts. But then going that next step and starting to app modernize, starting to look at techniques where I can break off those long running tasks. I can take bits of the application that I want to optimize and modernize, and that's where we start to re-architect and do that modernization. All right, so I have a couple more slides here that I want to run through. Hopefully I can hit the button correctly now. Don't want to play from beginning. Sorry, I'm using this in the VM, and I don't typically run PowerPoint on this Word or PowerPoint online version. And I guess this is why. So the next few slides are really just kind of getting into some best practices to keep in mind for a modernization effort. Okay, we're going to go with this approach. So in terms of best practices, one of the principles to a successful migration, modernization is the first thing, and then we'll get into some of the best practices. So in order to have a successful modernization, it is important that you understand the application modernization roadmap and prioritize that with the business capabilities and strategies. I think that goes hand in hand a little bit with the next one, which is balancing the business technology factors with the application portfolio. We need to understand which applications are the most important, which ones can we just move to do the lift and shift, which ones are we expecting to have new features on, how do we kind of grapple, what type of demand the application has, what type of support it has from a development perspective and a product ownership perspective. And understand that in a comprehensive way as part of the roadmap, which is really that kind of gets back to the Microsoft Cloud Adoption Framework and their recommendations to make sure that before you undertake this, you have an understanding of what you're trying to do. Part of, if you just do the lift and shift, I think there's something that you're kind of losing out. And a couple of these are really the ability to empower your workforce to start using some of these emerging technologies. It's one thing to get your application deployed and start to save some benefits from an IT perspective. But it's a totally different thing to be able to get your developers to start embracing those new technologies and starting to understand some of the architecture benefits and starting to incorporate that as part of a downstream development process. Agile DevOps is another good example of something like that. If your applications are taking a long time to be deployed, understanding some of these modern technologies is certainly going to help you embrace the cloud. In terms of thinking of things from a platform as a service perspective, understanding application and data go together. So modernize the data and modernize the application with the data. Don't kind of separate them and keep your data, don't look at it as an opportunity to keep your data on premises and, just use the cloud to migrate to house your web applications. Look at modernizing them together. There's a number of different data modernization techniques as well in terms of how do you distribute your application so that you can scale your database along with your web application that needs to be included as you look at modernizing your data as well. So eliminating redundant functionalities and investing in new features. A great opportunity to kind of look at how your applications are being built and start thinking about maybe microservices opportunities. How do we kind of take functionality that exists and separate it out so that it can be shared across multiple applications in a web API or some other form. And then identifying some of the performance baselines and KPI measures. Part of what we typically do as part of our Azure readiness with customers is understand kind of where they're at, both from a cost perspective as well as from a performance standpoint on some of their key applications, and using that as a performance baseline so that after the migration is completed, we can kind of compare against that baseline and make sure that the cloud is delivering on what was expected there. And that comes similarly with the maturity part. define the path that you want to do for maturity, and really sort of measure that and make sure that you're achieving the goals that you want as part of your migration. These are some kind of architecture and design technique principles to understand for a successful migration. Designing for self-healing. There's an old kind of story about Netflix and their idea of a chaos monkey, which was a technique that they would use to randomly shut down servers and make sure that an application was not only able to self-heal, but also was able to be fault tolerant to something shutting down. And the chaos monkey kind of was always just randomly throwing wrenches in the development teams. The way they handled the software, because it was shutting things down, and you'd have to respond to that. And if your application didn't work and didn't respond properly, there was new features that were added to make sure that it would handle that in the future. As you start looking to deploy to the cloud, it becomes very easy to kind of set up redundancy. So you do want to look at building redundancy into your application, not having a single point of failure. The architecture that we showed with the queue is a very good technique for some of that as well, because it becomes a place to kind of store up your application state and some of your history, so that if a server goes down, as soon as it comes back online, as we kind of showed where we turn the queue back on, it'll go ahead and pick up all the changes that need to be made and execute them, so that you don't lose any data as part of that. You do want to design your application to scale out. There's a number of concerns as part of that. Specifically, the scaled web application demo that we showed, where we're using a queue to kind of manage the order in which data is being voted on, is something that's a key principle as part of scaling out your application. You can't just throw a bunch of additional servers out there, because then things can start happening out of order, and that might not be good for your application. So being able to understand how scaling out impacts your application, and understanding where to adjust the architecture is going to be critical to really making sure you're able to scale your application properly. Minimizing coordination, and as I said, that's kind of the ability to really make sure your application doesn't have a ton of components that you don't, or a ton of services that you have to manage to make sure it's up and running, and have to be fault tolerant around. The less services that are involved, the better. Partitioning around limits. When you start looking at scaling out databases and your data, you need to understand where to partition it. So a typical technique might be to partition regionally, but you may have other techniques to partition by business unit, in order to make sure that your data is still performant, and you're not having to go across partitions for many of your queries, and you're also able to keep the data locally centralized, so that the data is responsive for the people that need it. The using managed services, I think that was hopefully my big point that you guys got out for today, which is using platform as a service whenever possible. Infrastructure as a service is an option to go to the cloud, but it's not going to be your best option. And the more you can go to the platform as a service, the better off you'll be. And then designing for evolution. Again, you want to make sure that your application is set up to change over time. The continuous integration, the deployment CI/CD pipelines is going to be part of a key feature to that. We always like to go with a deploy early and often sort of approach. The idea there is that if your team is really good at deploying their software, that in the times where they need to critically deploy something quickly, they're very good at it. So it may hurt to do deployments. We had one client one time that took 60 days from the time that they had their code freeze to when they were able to get a bit of code out deployed to production, because of all the red tape that was there. So obviously there's a ton of pain in that company around deploying an application at all. And so setting up a CI/CD pipeline forces you to kind of address those pain points, and it hurts, but at the same time you come out the other side being way more efficient as part of that ability to evolve and innovate with new features. And then build for the needs of the business. I think that kind of comes back to the beginning part about having that plan and that guide, that roadmap attached to your portfolio, so that which business units are going to benefit the most from a move to the cloud, and taking advantage of those. Did a little client recent case study that we wanted to show. I mentioned this a little bit as part of our COVID-19 response, but we worked on a remote voting application. This was an application that was born in the cloud. It is designed to have a queue so that the votes this was from the House legislatures to manage their voting while they were in session. So being born in the cloud, it had the ability to scale up and scale down. So most of the time when House was in session, it's not really using much of a footprint within Azure. But as the House was in session, they started creating items to vote on. You could quickly scale up the servers. It also used like I said, the queues in order to manage the votes, because lots of votes would be happening at one time. And then the final part about this was that it enabled them connectivity to additional services. So in this case, there was multi-factor authentication that was used as part of the logging in, and they would get an SMS message with the token. That SMS message with the token was created through a service called Twilio, which is available, which was connected directly through the Azure services in order to give them access to sending text messages within the application. The last item I wanted to kind of share here. So in terms of the cloud adoption framework, we at Tallan, we're a Microsoft Gold partner. We work with a number of clients on their Azure migrations. There are two different offerings that we work with customers on in order to kick off their cloud adoption framework. One of them is more of an Azure Foundations if you're just getting started. But the one I wanted to highlight today around App Modernization was an App Innovate. So this App Innovate offering is something that does come with Microsoft funding. What we essentially do here is a three-phase process where we plan and we identify 1 to 5 kind of candidate applications. So we look at your entire portfolio. We try to help with you assess what is a good variety of 1 to 5 applications that we can do a modernization around. If you also just have a single application that you want to modernize, that's been an area where we kind of can scale on the planning because we know exactly what application you want. From there, we do some architecture design requirements. We do a working session where we walk through the application, understand what the kind of to-be architecture plans could be and what new architecture features you might want to take advantage of, and then create a modernization plan for what that application could look like and whether it needs to be replaced or migrated or modernized as a result of the assessment. So again, this is a fun engagement from Microsoft where we sit there and we work with you to go through a specific application or a number of applications to help guide you in how to architect those for the cloud. In terms of the deliverables, it's really kind of a two-part deliverable for that offering. We have a vision, which is looking at where you're at, what the current architecture looks like, how much that's running, and what the estimates would be to just run it over in the cloud, and then a roadmap for what the to-be architecture could be, what the licensing would look like, and then what a plan could be in order to move that application. And then finally, if we were to provide any additional services or recommend any additional services, we would provide that as well. In this deck, I'll also include a number of different resources. So we have the migration guidance that we talked about, some of the Azure migration assistant tools that I spoke about, the architecture documentation. So when we look at both the migration documentation and architecture documentation that's included here, and then finally some pricing around app services and Azure SQL databases. So I was a little nervous on the timing. It looks like we're kind of right at the hour, but I'll kind of leave it there for any questions. I think we have everybody muted. If you want to go ahead and unmute, you can feel free to just holler out your questions, or if you feel more comfortable adding in the chat, that's acceptable as well. But any questions from the audience? Anything in the chat?
Hey, Ben, we do not have anything in the chat right now.
Okay. Well, I thank you everyone for your time today during your lunch hour. I hopefully was able to kind of show you a little bit about how we can, demystify that cloud optimization part. Really take much better advantage of some of your, the platform as a services, and not just look at shifting VMs. And then from there, that's really going to be your opportunity to start dipping your toes in some of these new features and some of the, the queuing and the modern tools that are going to be available within Azure. All right, have a good rest of your day, everyone, and thanks for your time today.